guys, and welcome to Chapter 9 on stoichiometry. Tonight we're going to look at basic stoichiometry problems and how to set them up and calculate them. So what is reaction stoichiometry? Well, it is defined as a mass relationship between reactants and products in a reaction. So we're going to eventually know how many grams of a reactant we have and how many grams of a product then we should get. So the key here is that you must have a balanced equation. So that balancing from Chapter 8 is going to come into play here. So you must continue to make sure every equation you get is balanced before you start to do these problems. So now we're going to look at a general flowchart for all stoichiometry problems. So in your notes you have types 1, 2, 3, and 4. We are going to put them all together so you can see the whole flow at once. When I'm done going through the whole process, then I will show you how we can break down this flowchart so that it covers each of the 4 examples or the 4 types that you have in your notes. So for a second, you're not going to write, you're just going to watch, and then you can go back and copy stuff in. So since stoichiometry is a mass relationship, we're going to start with mass, which is using the unit grams. So we start with grams of A. What is A? A is any substance. In the equation, it could be a product, it could be a reactant, it's just whatever we start with. Then we're going to times a line, like we've done before. Every time we start with something, we times a line. We want to get rid of grams, so grams is going to go on bottom so that we're going to be able to cancel out our grams. And what do we change everything to? We change it to moles. So if I were to stop my problem here, I would have changed my grams of A into moles of A. Now you'll see we've got the 1 written in here. That's because when we have grams and moles together, this is always 1. We are going to change the number in front of moles sometimes, but in this case, when we're working grams with moles, it's always going to be 1. So then where do we get that number from? Well, that we look up on our periodic table. So we just use the molar mass of the compound. That may mean you need to look it up and add it up. If it's a single element, you just need to look it up. So it all depends on what the molar mass is. Again, you get these from the periodic table. Now, once we're in moles of A, we can cancel out moles of A, again, by putting it on the bottom. So, if we put it on the bottom, it cancels out. Now, we can change moles into moles. But you'll notice, what did I change? I did change something. I changed the substance. This then allows me to get to moles of B. So this is the substance I started with, or what was given in the problem. This is what I want to change to. So that's where my A and B come in. And then we don't have any numbers there, so where do we get those numbers from? We're going to get those from the coefficients. So again, you had to balance that equation. Those numbers then are our mole ratio. This is in class what we drew on our hearts that we cut out. Once we're then in moles of B, if we want, we can change that back into grams by putting it on bottom. So again, moles will cancel out. So just our dimensional analysis, our idea of crossing out units. We're going to change it then back into grams of B. If we did the math, we'd be in grams. So now we have, or we changed from grams of A to grams of B over here, and we've shown a mass relationship. You'll see again, we have 1 mole of B, which is going to always be 1 mole. But then where do we get that number? Again, we use the molar mass. Okay, so now I've taken all of my writing off of here. How do these fit into numbers 1, 2, and 3? Well, number 1 is a mole-to-mole type of stoichiometry problem. So you can see in parentheses I have that you are going from moles of A to moles of B. So this is where I would start, and this is where I would end for number 1. So moles of A, mole over mole, and I'm going to get moles of B. That means that none of this is in there at this point. Number 2 says you want to go moles to mass. So we're starting at moles of A, and we want to change it into mass of B. Now remember, mass, the unit is grams. So again, we are going to start here, but this time we're going to end down here. So the only thing we're getting rid of is this part. So we start here in this box, go through our mole ratio to get moles of B, times another line, change moles back into grams. Number 3 is mass to moles. So now we're going to start with the mass of A and change it into moles of B. So again, mass unit is grams. So we're going to start here, and we are going to end at moles of B. So we've dropped off the end part, but everything else stays the same. You can see how we are using this same chart over and over and over again. It's just a matter of where are we starting on this chart. Should you memorize it? Sure, but it's really not that hard to memorize it. This process is going to be the same, and I think as you start working with it more, you're going to see how much more easy it is to run through this process. Once you get the hang of it, once it clicks, this isn't a hard process to work with. So now what if we want to do number 4? Well, there's number 4 right in front of you. This is where we're going to start, and this is where we are going to end. We are going from mass of A to mass of B. So you can see in every problem, number 1, 2, 3, and 4, we had for you our mole ratio. So every problem must have one of these, which is why we cut them out in class and we saved it, and it's on brightly colored paper so that you always remember every stoichiometry problem you do from here on out needs to have this type of ratio where you're changing from moles of A, which is why it's on bottom, because we're going to be canceling it out with whatever we start with, and changing it to our moles of B on top. So you must have that ratio in every problem. And of course, our numbers that we use come from the coefficients of a balanced equation. So if you aren't good with balancing, you need to keep practicing, because the balancing is going to be the important part. Otherwise, our numbers in the end are going to end up wrong. So now a few hints for doing these problems. You can only change one thing at a time. So what does that mean? Well, all of our units basically had two things. We had a substance, A or B, and we had a unit, grams or moles. So when we are doing these problems, remember, you can only change one thing. So we can change our unit. We can go grams to moles or moles to grams. Or we can change our substance, which means our moles stay the same so that we can change between substances. So here we change the unit, substance must stay the same. Only change one thing. Here we want to change our substance, so our unit must stay the same. We can only change one thing. Now the tricky part is when you do that type number 4, you're going to want to do just grams to grams. If I can do moles to moles, I can go grams to grams. I'm still only changing one thing, Mrs. Santiago. Well, yeah, you are, but it doesn't work, because grams for every, or the molar mass of every element is different. However, when you change it to moles, now we're talking about a constant. We're talking about 6.02 times 10 to the 23rd molecules. That is a constant number. So the moles that go with that are going to be constant, or the number of molecules in that mole is always constant. Yes, the numbers may change because of balancing the numbers that you put in front, but that's fine. you're still basing them on a constant. So that's why we have to change everything to moles, and we can't just go grams over grams. Practice number 1.